All right, good evening. It's Mark, KA6WKE, you virtual Elmer. And this is a pop-up live stream for, to finish up the Saturday's live stream on building your first kit. I ran out of time, and then a viewer notified me that my audio was horrible, and they were right. So I spent some time this evening getting it fixed. And while I was at it, it should sound a lot better now. While I was at it, I also worked on my video, getting that sharper. I noticed it wasn't as sharp as it could be. And with my little Logitech webcam here, So what I'm going to do this evening is finish up your first kit. We populated the board, and we left it ready to do an inspection on it. And what I like to do for my projects is when projects are done, I like to set them aside for a little while, like a couple of days, and then go back over it, double check everything, make sure there's no solder bridges or anything like that. You want to be careful, be methodical with your projects. I like to work left to right, top to bottom on every single project, so that way I know I've covered the entire board and everything looks good. So according to the directions in the manual, they wanted you to pay attention to there we are. They wanted you to pay attention to the orientation of the integrated circuit, our amplifier, the LM386N. Also pay attention to the orientation of the transistor. Now, resistors, it only matters in orientation for reading the color codes, the bands. So I like them left to right when I'm looking at a board. I like things like disc capacitors that have their values on the, imprinted on the side, on the left side, and also if they're facing down on the down side. So that way I can see the whole board just by looking at it without having to go to the other side of the board to read a label. Electrolytic capacitors you have to be a little careful with because they have an orientation you have to pay attention to. If you don't, and you power your system up, it's going, power your project up, and you have an electrolytic backwards, you will get a nice surprise, and it won't be a good one. So, what I do with electrolytic capacitors is I make sure that the values are up on top, so you can read them, and for troubleshooting purposes. Sometimes some people or some assemblers put the values on the bottom, and then that makes it really difficult to read. Just double checking the audio. Okay, so that sounds a whole bunch better. All right. So moving on, you flip the board over and you take a look for any solder bridges, especially around integrated circuits where there's not a whole lot of room between the legs of the IC, in this case our IC socket. Transistors can be close together. You can see here, it might be able to bridge that if you have a real fat tip, and you don't want to do that. The rest of the joints look good. They're shiny. They don't They don't exhibit any of the bad joints that was provided by the Adafruit graphic. So there wasn't too much heat. We don't have any cold solder joints. They all have enough solder. We don't have too much solder with a big ball on it. They all look pretty much just like this, just like the perfect one. So going back to this, looking at the schematic, or the board layout, I should say, there's a battery connector that we need to connect. And we need to pay attention to how that's connected. You don't want to reverse polarity on your project, because that will let out all the magic smoke. Trust me, it has happened at least once in your career of building. And if anybody tells you they haven't, they're liars. Everybody's done backward reverse polarity. Now there are ways to do protection circuits and things. This doesn't have that. Maybe that's a good tutorial to go over, is how do protection circuits work. Maybe build one. But for now, we are just going to put our leads on just like it says. It's like it showed in the board layout. So the black leads on top. We have the board in the correct orientation. We have negative on top. And if you notice, this capacitor, look at that capacitor. What do you think about it? Yeah, it's backwards. Somewhat intentionally, actually intentionally. So during the episode 5, we learned ways to fix our goofs. And we'll do that right now. So this will be pretty straightforward. What we're going to do is get our solder wick. And this solder wick has rosin already in it. It's impregnated. So we will remove the solder by dabbing. Remember, do not drag. If you drag, you'll rip the pads off this board. And that's something you don't want to do. We could fix it, sure, but we really want to dab and let the solder wick do its work. You can see there it removed it pretty good. Now we have to go all the way to the top of the board. And that's funny, I'm watching this on the monitor while I do this. We want to pull that off. Still soaking up some solder. All right, can we pull that out of there? What do you think? Can we take it out of there? I don't think so. I think we're going to break out the solder sucker on this one. That just has a little too much solder in it. So, just like we've shown, you heat the joint up. Put the solder sucker straight on there. Give it a pull. All right, so that pulled out. You can see the hole now. And we got it on both ends. But I don't think we'll be able to take the board out, or the right away. Yeah, because I bent the leads out just a tiny bit. So what we'll do is quickly heat it up and let it pop out. Oh, this one's going to remove on its own. Look at that. Okay, that's how you want to remove your parts. If you have to tug on it, you're going to ruin something. Most likely the board. You could tear the leg off the the capacitor, and then hopefully you have another one in your junk box for to replace it. So never force removing something from the board. If it doesn't want to come off, there's a reason. So let's get that back in there and put it back in our holder. We'll resolder this down. Double check. Did I accidentally? Yeah, there we go. This goes to negative. This goes to negative now. Right on top of where, if you look at the board layout, you'll see the black lead of the battery connector going straight to the negative. Okay. Whew, dodged a bullet on that one. Holy cow. Well, maybe not, but still. That's why you want to double check your work. So we'll give it a little solder it back down here. Remember, let the joint heat and then feed the solder in, just like that. Feed the solder in just like that. Perfect. Nice and shiny. Not too much solder. You can see right there. Looks nice and shiny. All of them do. All right. So now we got. Now the electrolytics are in correctly. Now these are non-polarized, which means they can go in any direction or orientation. They can be placed on the board, but I like to make them right readings from top to bottom. Okay, so you can see the values, the value and its ratings, nice and easy. That one on top has the negative lead on that side of the board. So let's double check. Oh, I don't have the schematic up there, but let's check. Yep. According to the board layout, negative's on top, and that's where this is. Okay. All right, so let's trying to work on some different lighting around here. Definitely focuses better when it's got more light. But then yes, this side gets washed out, so maybe a diffuser of some kind should go on there. Okay, anyways, thinking out loud here how to improve things. We'll put the battery holder in. This is already tinned. Yeah, it's freaking the camera out. Use this one. So it's already tinned, it's ready to go. Both of them are. And when you're using stranded wire for your projects, you want to tin the ends a little bit to keep it from fraying when you put it into the board. Okay, those little frays can sometimes become a problem, and you don't want that happening. So these aren't going to stay in on their own. So we'll cut a little piece of electrical tape to hold it in while we solder it. Pair of scissors. Have a pair of scissors by the bench. See if I get it to focus again. Sometimes it focuses. It's kind of strange. Then it. Yeah, there it goes. So we'll put the leads of the battery connector on. All right. Kind of twist them into place there. first. Put positive in second, just enough to squeeze it in there. Flip it over and we can see that both battery leads are there. We need a little bit of solder. Some people pronounce the L, some people don't. I'm not sure it matters. All right. Okay, there we go. All right, so now we can do our first test. Before we plug the battery in, what you want to do is you do want to do a continuity check with your digital multimeter. But first, we take our amplifier IC out carefully. You don't want to bend pins or like it'll just pop out. Set it someplace safe. And then take your multimeter and put it in diode mode if you have it. If not, just put it in resistance mode. I use diode mode. And we want to check if we have a short somewhere. So we'll do a quick continuity check. And we don't. Looks like we're good. Let's flip it around just in case there's diode action going on, because diodes only conduct in one direction on DC current. And we're good. No shorts. All right. Set that aside. So now we need 9 volts. Now you can use a battery. Let me. I don't need this any longer. Remove it. Okay. So you can either use a 9-volt battery, and that's fine. I have a whole package of them in there. It's supposed to go in my smoke alarms that I haven't done yet. This board's getting world walking. Yeah, let's tighten this up a little bit. There we go. That's why I like this. You can hold the board nice and snug and give you a way to tilt it around. All right, so we can use 9-volt battery. To power it, or if you have a bench power supply. So I've got one here, 0 to 30 volts, 0 to 5 amps, a 2-channel for that, and a +5 3-amp output. It's all variable. You can do current limiting on it, so you could power this up with a limited amount of current. And just to make sure it's not going to have issues, we will put our integrated circuit back in, and we have one more thing to finish. Okay, that just presses in. There you go. Both sides, you want to make sure that they're both sides of the legs are fully seated in your socket. Now, normally I don't use sockets. I just solder the thing down to the board. But for this project, they gave me one, so why not use it? So we have 2 things left. We know we're good on voltage. We know there's no shorts. We know there's no solder bridges. We know there isn't any other issue with the board. All the parts are installed correctly per the board layout in the schematic. So all we have left is to finish this up. I shouldn't have deleted that one. I should bring it back. Okay, So looking at the board layout, let me find display colors image. Oh, hold on, I got an exhibit in there. Oh, well, thank you, Open Broadcasting Software. Ah, there we are. Okay, it's back. So looking at the board layout, speakers are at the top. Now in this case, it doesn't matter what polarity this, which leads positive, which leads negative, because we only have one speaker. If we had two speakers, we have to pay attention. Like in a stereo system, you don't want them out of phase, as it's known. Oh, well, I can delete that one. Nope, I want to rename it. I want to get rid of it. No. Still messing around with Open Broadcast software here, but I like it. I think it does a good job. So we will strip this off. So I'm using my little one. It's got this one goes from 22 gauge to 30. This is probably 22 gauge, and it is. And yeah, so you just strip off a piece, a length. I like to strip them off same length, and that will put that on the speaker end. I've got another thing of wire here. Okay, so that's for the volume control, but the volume control, oh, they put it in backwards on the, so I can't just solder it down on the board. By looking at the assembly instructions, you'll see that the right and left outer terminals are crossed in the wires. So if you want your volume to increase going clockwise, you have to wire it that way. If you don't care and want to go the opposite direction, you can do that too and just solder it to the board. Just realize it's going to be an issue. So we'll give you some really high quality wire too. It's nice. It's already plated or tinned, and so we get our little piece of electrical tape back. Flip it back over. I left these a little long, but that's okay. Solder the bad boy down. What happened to my pieces of solder? Notice I didn't touch the joint, and I'm using the flat side of the chisel against the wire because it has the most mass compared to thermal mass compared to the board. So that way, nice solder job. Look at that. Nice, and it's got nice peaks on it, not too much. No cold solder joints, nothing like that. So that's what you strive for, and it takes practice. So don't get hard. Don't be too hard on yourself if you create a lot of solder joints and bridges and things. Everybody's done that while they're learning. Okay, so that's going to go off to the speaker, which we will attach here in a moment. So actually, looking at the speaker, you might be able to see, yeah, you can see that it's got positive and negative markings on it. So looking at our board, which one is positive and negative? If you guessed this one is negative, you are correct, because you can go by the negative lead of the capacitor. Okay? So that makes this one positive. So now we can pay attention to that once we solder it down. All right, set this aside for now. Now we're going to solder up the volume control knob. So this needs 3 wires, and you're wondering, well, how can we make 3 even length wires? So here's how you do it. You make your 3 wires. Make your 3 wires, and you just keep expanding them until they're all sides are the same length. They're pretty close to the same length. That way you don't end up with any extra left over. One's too short, one's too long. You know, it's these attention to details that you want to have when you're working in electronics. Some of it's so your project works. Some of it's for keeping you alive. If you're working on high voltage equipment, and I will be returning to the desktop kilowatt amplifier here after the first of the year, we got the power supply to test. Being diligent and paying attention can save your life. All right, so this is going to be a little longer, but that's okay. I'll cut these off right here. Strip them again. Get these all ready. Now these are different type wires. So the wires that I installed, that I put on the board for the speaker, are actually Teflon coated wires, and they have a very smooth feel to them. And the higher quality wires do have they are silver plated, probably, or have a very high quality tinning. So the wires that we're working on now are not. These are PVC wires. And what's going to happen is they will melt. Okay? You have to be off and on it real fast. Okay? So that's tightly twisted together. We'll put a little solder on the tip, and we'll quickly tin these on the ends. Okay. Nothing crazy. You see how quickly it melted backwards? So I don't like PVC. I don't like PVC. But it's what they supplied in the kit. But hey, it was a $15 kit. Just get that little whisker off there. Okay. Good enough. So we're going to place these back in the board, and they go right here. Oops, I missed one. See, a little hair got out there. I'll just twist that in real tight. And it goes. Same with center pin. And center pin goes in, and we are going to tape these down, just like we did before. place. And flip them over. And one has already pulled out. That one, the very end one, came out. Okay, there it is. 1, 2, 3. 1, 2, 3. And it needs to be soldered down. So you heat the opposite side of the joint and you push the solder into it. You don't do this and then solder, okay? Don't touch it first and then solder. You'll need to do that. Can be done though on surface mount projects. Come on, just focus for me. There we go. On certain surface mount projects, I will show you. Require, you know, you'll put solder on the iron first, and then put some flux down on the board and solder away. So there we go. We got our volume control in there. Nice and neat. And I didn't melt too much of the PVC solder, or PVC wires. Jacket, that's the word I'm looking for. It's getting to be bewitching out here in Southern California. It's 20 after 8. So, I get something put away here real quick. All right, so now we got everything pretty much wired up. Got a mount speaker. We have to mount the potentiometer on the end. So we will strip the end of the wire like so. Sure we're good. All right, oops. See how that split? Yeah, roll it tight. Twist it tight. So now we got to put it on. Put on our volume control. So according to the board layout, the center goes to the center. Okay. So this version has legs that can be installed directly on the board. But then the volume control would be backwards. We don't want that. You can also solder the wires through the holes. I didn't realize how fat my finger was. Through these holes too. Now I wouldn't use these. These are just used to keep the leg attached. And they don't always go all the way through. See, it looks like there's a little bit of a gap down there, but use the main holes up here if you're using wire. So we'll cross them so we don't get goofed up. I crossed the wrong ones. So, no, I did the right ones. Here's the center. And here are the right and the left. So we will bend them over, set it in there, and bend it over on the other side so the wire stays. Okay. Now the center goes in the center. That's the wiper inside. And this side goes here. So on a potentiometer, the two outside legs are the full resistance. So if you don't know, if it's not marked, this one's marked, so we know it's 50K. If you don't know if they're not marked, you can put your ohm meter across the two outside and determine the value of the potentiometer. It's a little more difficult to determine linear versus audio, but it can be done with an ohm meter, and maybe I'll show how to do that. So we got our volume control right here. I'm not sure if it'll stay. Okay, hold on. Let me get my other one, and we will use two stands on this. That's not going to work either. What can we use? Just need something to give it some weight. Yes, having a set of alligator clips can be very handy. Boy, this one keeps rotating around. Hold on, let me give it a leg so it doesn't rotate around. There we go. Just hold it there. Make sure we got the wire all the way through. And we'll solder from this side. This will be easier. This might take a little more heat because of the thermal mass of this. Well, it's essentially a rivet holding the leads on. So I put the fat side of the chisel on the wire and the little rivet. So soldered up real easy. Put some more solder on the tip because I don't think I'll be using it. So there we have it. We have our almost completed amplifier volume control. And now we need to solder in the speaker, and we got it. Okay, so we know the left side is negative because of the capacitor, and that's the positive. So the positive on the speaker, faintly make it out. Oh, there we go. Give it some. There we go. Is on the right side, negative on the left. So we will bring this up from the bottom of the connector. So we bend the wire up 90 degrees. Bend the other wire up 90 degrees. Okay. And then feed it. Careful, don't poke a hole in the cone like this. Okay, so you want to give it some little bit of mechanical strength there. That'll be okay. And then we put the other side in, the negative side in. I could have cut these a little shorter, honestly. Let me tin that in just a little bit here. Okay, let that cool off. Now the Teflon on this won't melt. I mean, it will give enough heat, but not off a typical soldering iron. And the dwell time, if you remember, is the amount of time you spend on your joint, not the kind you smoke. Okay. Well, I guess you could, maybe. So we'll fold this over. I'll clean this end up. I should have soldered the end on this too. There we go. Time to solder it down. Let me move this into the shot. Now, when soldering speakers, you got to be careful because the cone, the coil that's attached to the cone is soldered right there. If you heat it up too much, you could disconnect it. So we will be very careful. Apply the iron, fat side against the wire, and just a brief touch. So there you go. Same with the other side. And a brief touch. It's wired. So now what I'll do is cut this little piece off the project and make sure it's no little pieces of wire come off. And we have it. This is our project. Volume control is in. Speaker is in. Now we get to decide on what kind of input are we going to use. So this amplifier kit has two inputs called signal 1 and signal 2. So signal 1 is for much lower level inputs like a record player, say, or a microphone, and that's what this transistor does. It increases the signal large enough so that the amplifier chip has a strong enough signal in order to amplify it even louder to a speaker level. Okay? Signal 2 goes straight to the 386 amplifier. So we will be using that one. You want to use that one for things like connecting the output of a scanner or the radio that only has headphone output and a really cheap internal speaker like my scanners do. And you can boost them up to a nice level, nice volume. So we want to do signal 2, and that is right here on the board. Now we need to determine which one is ground. Well, for us, it's already on the board layout. We know ground is up here on the input. Interesting. So why, if the ground on the input is here, and it goes to the positive side on the speaker, signal 2 in goes, it's connected to here, goes to the input of the chip, the 386 amplifier, and comes out on pin, hold on a second, comes out on pin 5, so 1, 2, 3, 4, 5, right there. So this pin, interesting. I'm not sure why the negative lead of this capacitor is. Oh, yes, I do. Oh. No, it's right. Okay, you have to look at the schematic. So what this capacitor is doing, it's decoupling any DC voltage that may be on the output of the 386. So it doesn't reach the speaker. Only audio, only alternating current AC signal will reach the speaker. So that's what they're doing here, looking at the schematic. All right. So we're going to need to connect 2 more wires there, which I used up all the ones that came with the thing. So I will get, I've got a bunch of spools of wire over the years. And I will get some nice red Teflon coated. About 6 inches should be sufficient. And some black. Same length, 6 inches. Okay. We will strip those, solder them to the board. Yeah. I'm going to slide it a little further out of the way here so we don't melt the melt the circuit board holder. So red is input. Bend the wires, red is input, so negative is here. We can give it a little bend so it stays in. Oop, fell out. Here. Put that, oops. Flip it over. I should have done the speaker last. Didn't think about it. Okay. So now we've got our inputs right here. And we will solder it down just like last time. Fat side on the wire of the chisel. And then push it into the joint. You don't touch this. Don't touch the, I think that slipped out some. Yep, slipped out a little too much. So we'll just heat it back up again and push the wire in. It's going to be hot. Okay. Cut off the extra. You don't want to leave anything extra on there. It's red, black. We're okay on that one. All right. Flip it back over. Oh, black is still way. Look at that. So that's not good. You don't want to have. You don't want to have this much exposed wire out. This is okay. The positive's okay. Could be a little closer, but it'll be fine. But this is too. This isn't good. So pay attention to the details again. Make sure you don't. Go over. So how are we going to fix it? We are going to reheat the joint and then use a pair of smooth needle nose pliers. And we're going to reheat the joint. The joint's right here. And push it through just like that. Yeah, that's better. And then trim off the excess. All right. So now we are ready for our first power on self-test. We got our speaker connected. These are our inputs. Here are our inputs. We got control, which is turned all the way down, and 9 volts. So I don't have a 9-volt battery. So I will use my lab supply, channel 1, dial it down to 9 volts. we want to limit. Oops. We want to limit the current to 1/10 of an amp. For now. Okay. And then I've got to find my, oh, there, power supply. We plug it into channel 1 of the lab supply and pay attention to colors. Red to red, black to black. You don't want to accidentally reverse polarity on this. Now the big question is, I don't remember the 9-volt battery polarity. Let me look that up real quick. It's nice having if you can have a computer on the workbench. Okay, so positive, I had to look this up, can't believe it. The positive is the crown type connector. So we'll take the positive side, actually we'll take the negative side first, hook it to the negative side, and then, oh, listen to that. We got some noise. Actually, the drawing is incorrect. The volume control is backwards. So don't follow this side. No, okay, I see the orientation. So we have a repair, a little fix-it thing to do, but this is great. Now you can hear some music in there. The reason for the music is that I live about a mile away from a 50,000 watt AM broadcast station. And my body's acting like an antenna and a demodulator. So that's why. And our amplifier's working. It's drawing, other than the audio, let me turn it all the way up. Okay, that was the all the way up. It is drawing 44 milliamps at 9 volts. And there you have it. Your first kit. Now this kit can give you, there are other ideas. Now obviously you wouldn't leave it sitting out like this, or maybe not so obvious, but you don't want to leave it out in the open. So that's one of the reasons why it's picking up that AM radio station. So what you can do, this will fit in an Altoids tin nicely. These were very popular way to package something. So this will fit in here like perfectly. Okay. So yeah, this board will fit in here perfectly. You could use some double-sided tape to stick it down. Actually, there's enough room if you push it all the way to the end. There's enough room for a 9-volt battery in here. Or you could power it off a linear AC adapter. Don't get a switcher, but get a linear kind. But only drawing 44 milliamps, I'm sure a 9-volt battery is going to last a while. You could replace the hardwired volume control and put it, this will have enough room here to fit. You could drill a hole through it and mount the volume here. You could replace the inputs with headphone jack, a mono headphone, 1/8-inch headphone jack on the other side, and you have a complete little amplifier to increase the audio of your speaker. You could put a speaker jack out there too, and maybe don't use this little tinny thing, but you could always use a regular external speaker, something like that. So there's some more options to finish this project, and I'll leave it to the viewer to decide how they want to do it. So that's it. That's your first kit. From start to finish, learning how to solder, safety. Safety was first, learning how to solder. Fixing your solder mistakes. We had a mistake on the board. I put that cap in backwards. So we were able to use some solder wick and some solder sucker to remove that part and flip it around. Described how potentiometers work, and I can easily flip this around now. Actually, what I would probably do is just unsolder it and solder it down to the board. If I decide to use this for some other application. We went over all the different tools. We went over solders. We went over fluxes. And that pretty much covers it. So I'm going to say goodnight, 7-3. Thanks for the ride along. I hope I didn't spam everyone with all the testing I did tonight to get the audio worked out. So until next time, there is no live stream on January, the first Saturday of January. I'm going to have family and other stuff going on, probably just like everyone else. I will resume on January. I can use my phone. So let's see. So there's no live stream on January 5th. I will resume on January 19th. And more than likely that one's going to be testing the high voltage rectifier board for the desktop kilowatt amplifier. There are some other tests to do on the tetrode boards. I will probably do another pop-up to finish the second tetrode board, which I got mostly built, except for a lot of the discrete things. I didn't put those on. And we'll be able to follow the directions in the manual, hook up some voltages to it, and run some tests. And then for that project, all that's left is to create. I had to build a chassis for it, which I'm not going to do live. There's just too much cussing and things for me on some mechanical things. So I won't be doing that. It'll just be ready, and we can go from there. So have a Merry Christmas, Happy New Year, and I will hopefully you'll be viewing next time. 7-3.